I just thought I would do a session about prepping for fieldwork and just kind of answering fieldwork questions, because it's one of the trickiest geography concepts that they introduced a few years ago. You used to do your fieldwork and then do coursework, which was worth 25% of your grade, and it was lovely because you go in your exam knowing you had a bit of a buffer. And then the government wanted to make exams harder, so now they test you on the fieldwork that you did. Now, as a tutor and a teacher, it's really hard to teach this because people all around the country will do different types of fieldwork. One bit will be physical, one bit will be human, and you might go to the beach, you might go to a river, you might go to an inner city. So you're all going to be doing different things. But I just thought what I would do is go through just one example, so at least you can see how an inquiry works. That's what it's called sometimes, an inquiry or an investigation. You can kind of see the order of things and just see some practice questions and stuff like that. So disclaimer, this won't be your specific fieldwork necessarily, but there's definitely some ideas you can apply. So with that in mind, this is the kind of order of things. So you would have to start with the location, obviously knowing where you're going, but also justifying why. So I'll show you that in a second. Then you need to know what you actually did. We call this methodology, or you might call it data collection. So what did you actually physically do on the day to collect some data? Then, of course, you get your results from that. You bring them back to school and you analyze those results. You present them in graphs and things like that and try and work out what you found out. And then you conclude your work and answer whether or not you met your hypothesis. And then you can evaluate it and talk about improvements you might make or what stopped it from being reliable or accurate, which is what we'll talk about shortly. So the example I'm going to talk about is quite near to where I live. I don't live on Sandbanks, the fifth wealthiest place in the world. I live around the corner. That's about a 15-minute drive away. Okay, but we take our students to Sandbanks to find out if the hard engineering, that's the groins, is impacting longshore drift. And straight away in the photo, I can see that it is, but of course we're going to collect some data to find out. So with our inquiry in mind, we need to start the location. So why did we choose Sandbanks? Because it's got a spit, and that proves that longshore drift is happening. It also has groins, which are the hard engineering, and a go-to win for all of you guys, no matter what fieldwork you're doing, so long as this does apply. If you didn't travel too far, you can literally just say, because it was local. And that means that it was cheaper to get there. It meant we could spend more time conducting our fieldwork. It was safer as well, so we didn't have to go on loads of big roads. So they're the sort of reasons why we chose that. The first two reasons are always going to need to be linked to your hypothesis. So my advice would just be to read your hypothesis and pull bits out of it and say, what part of my hypothesis meets kind of where I went? Okay, so justifying the location. About hard engineering, what is hard engineering here? How do I know there's longshore drift? Because they have a spit, and that's caused by longshore drift. So the sort of questions you might get straight away at the start of your fieldwork section, Edexcel suggests 2 factors which should have been considered when choosing the fieldwork location. So you could say, proximity to school, how close was it? You can say, does it have the thing that I'm actually studying? Will it help me meet my hypothesis or not? AQA. Look at this, write the title of Physical Geography Fieldwork Inquiry. My biggest advice for anything fieldwork related is you have to know your hypothesis off by heart. Make some flashcards, one side write physical, on the other side write your hypothesis. Hard engineering impacts longshore drift at Sandbanks. Because if the examiner doesn't know what your hypothesis is, which they won't because they're marking exams from all different schools, how on earth are they going to know if you've got it right or not? Okay, especially when you get to the bigger questions. So you must learn your hypothesis. If not, stop what you're doing now, learn it. Okay, explain why the chosen location was suitable for the collection of data. So you would say, one reason is because it is close to school. Therefore, that's 1 mark. Therefore, we could spend longer collecting our data. 2 marks, linked sentence, move on. Okay, methodology. This is our data collection. So just so you know what we did, we measured the width of the beach either side of 4 different groins with a tape measure. And we did this at 4 different groins. The reason we did 4 groins is to make it more reliable. So a quick win, guys, for your exam. Reliable means repeatable. How can we make anything more reliable? Just do more of it. So in any question that you get, guys, how could we make our questionnaires more reliable? Ask more people, okay? How could we make our data collection more reliable? do it more times. Simple as that. And then some other things you need to be aware of. Is it primary or secondary data? And is it qualitative or quantitative? Primary data, which I'm sure some of you know, is data that you collect yourself. So physically taking a tape measure and measuring the beach is primary data. Like primary school is first school, you're the first person to do it. Secondary data is somewhere else, okay, that somebody else has done. So maybe you research something online, okay, or a census survey or something like that. Quantitative means numbers. So if we're measuring numbers on a tape measure, it's a quantity, it's quantitative. And qualitative, look at this, let me just read this up. Qualitative means literacy, lit for literacy. So that's words, that's going to help you remember that now. So quantitative, quantity, numbers. Qualitative, like a questionnaire or an interview, or photo analysis, anything that involves words, that's going to be qualitative data. Definitely worth knowing, guys. Okay, we also did some photo analysis, okay, just to compare some older photos to see if the sand's building up, to see if those groins truly are trapping that sediment. And again, is it primary or secondary? Well, this is secondary now because we didn't take the photo. And this is going to be qualitative, which I'm sure you know because it is words. We're annotating photos. These are interesting little couple of marks that you'll get in your exam. Understanding the risks that you found on your fieldwork. Again, is it for the physical one or the human one? Identify one potential risk in your physical fieldwork inquiry and explain how the risk was reduced. Now, this could be a generic one that you could probably use for any of your fieldwork, guys, is one risk was sunburn, and we overcame this by wearing sun cream. Generally serious, that would get you 2 marks in the exam. One risk was conflict with locals or stranger danger, and we overcame this by working in groups or having a member of staff nearby. Other more specific ones, like in my one, or if you're by a river, we ensured we didn't go near the water. That's how we overcame it, and the risk was drowning, okay? One risk was slipping on the rocks. We avoided the rocks. We wore suitable shoes. So this is a really nice 2-marker to get in your exam. So make sure you've got at least 1 or 2 up your sleeve. Okay, this is a bit trickier, but still only 2 marks. Justify one primary data collection. So now we know that our beach width measurement was primary. We can talk about why we did that, okay? So here's a really good model answer. If hard engineering is impacting longshore drift, we should see evidence of this increased deposition on one side of the groins. Therefore, measuring beach width on the either side of the groin was suitable to test our hypothesis. So I'm just linking what we did back to that hypothesis. We completed the method multiple times at several groins, so it was more reliable. There's that word again. And here's another word for you. It was also accurate because we checked the person's readings with someone else's to limit human error. So we need to understand the difference between reliability and accuracy. Reliable means repeatable. Accuracy, what do we do to try and remove error? Okay, there it is again. So accuracy near to the true answer with few errors can be improved with better equipment. That's a quick win, guys. How can we make it more accurate? Use better equipment. Tape measures are not always easy to use. The wind's blowing all over the place. We read the wrong numbers. Could we use a trundle wheel? Could we use a laser pointer? So think about your field work. What equipment could you have used instead to make it more accurate? And then reliable, repeat it. Okay, we did 4 groins, wasn't ideal. 2 of them had artificial sand dunes at the back, so it didn't show what we wanted it to show. So maybe we should do 8 groins to try and remove those anomalies. Okay, repeatable. And these are the results that we got. So you can see that groin 1 had more sand on the west than the east. So did groin 2, but groin 3 and 4 didn't. And that could be because of beach nourishment as well, where people are pumping the sand on the east side of the beach where there's more tourists and residents. Okay, so that's our results. We've done our location. We have done our methodology, okay, and now we're looking at our results. So now we need to think what we're going to do with our results. We're back at school. How can I really start to analyze the data? And the answer is to turn it into a graph, to present the data. But you need to know that some graphs are more effective than others at presenting data, okay? So for example, if we used a line graph to display this particular data, it doesn't work. Okay, it does not work. This would indicate that we are measuring the beach as we're walking along as well, between groin 1 and 2, between groin 2 and 3, and between groin 3 and 4, which we didn't. We took 4 separate readings. So we need to think, what would be a better way of showing this? And a bar chart would be the answer, okay? Because first and foremost, a bar chart might be easier to read, but the main important thing is, guys, you need to know the difference between discontinuous and continuous data. Discontinuous, it doesn't continue, it's just a standalone piece of data. Continuous continues. If we measure somebody's height versus their age, generally up to a certain point, it does this. Okay, that's a continuum. If we measure them every day for 18 years, it continually goes up. So a line graph would be perfect for that, okay, because it continues. Sea level rise would be another one. But if it's 4 standalone measurements, which a lot of yours will, whether you're measuring velocity in a river at certain points, whatever it is you're doing, discontinuous data requires things like bar charts. And that's what it looks like. You can see it's much clearer now. Definitely groin 1. There's more sand on the west and the east, so does groin 2. Okay, I can see that groin 3 and 4, that doesn't apply. So it presents it really visually. You need to think back to when you presented your data, what graphs did you use and why? Okay, because you could get some really tricky questions on that. So we've used a bar chart because it's very visual. It's very easy to read, easy to understand. You can spot clear patterns. You can make simple comparisons between data points. However, it's only useful for discontinuous data, okay? Why is that important? Because look at this question. Justify how your results were presented for your physical inquiry. So you need to be saying, for my physical inquiry, we used a bar chart. We did this because, however, a limitation of it was that. But overall, it was great because of this. Okay, so we've got to justify, why did you use a pie chart? Why did you use a line graph, a scatter graph, a radar graph? So please find out, what data did you use what did you use to present your data and why? Okay, and then finally, we can start talking about our conclusion. And you need to start thinking, let me go back to this. This is a big sort of 9 marker. Did we meet our hypothesis, yes or no? Did it show us that hard engineering is impacted by longshore drift? Because look at these horrible questions. And my biggest bit of advice for you guys is this. If you're ever going to plan any answers or bug the question, which means box the command word, underline the focus and glance at the mark scheme, for any questions in your exam, make it for the fieldwork questions. Because if you misread just one word, you're going to really mess up. Okay, if I go back to this question over here, justify how your results were presented. If that said collected instead of presented, that's a whole different question. That's a completely different question about what you did actually on the day to collect your data. But this is about how you presented it, okay, using graphs. So please highlight, underline every key part of the question. To what extent did the data for one of your inquiries allow you to reach valid conclusions? Title of your fieldwork inquiry. So to what extent, great, limited or no extent, how far do you agree that the data you got allowed you to reach a conclusion? So I would suggest one paragraph saying, well, yeah, it was great because it showed us this and we did this, so it was that. However, second paragraph, it wasn't fantastic because, okay, we made mistakes. Okay, we only did 4 groins. We should have done more. And then an overall conclusion. Edexcel, using the conclusions from your geographical investigation, assess the accuracy and reliability of your results. Tells me there straight away, one paragraph is on the accuracy, one is on about the reliability. And then again, you're going to need a third paragraph on an overall conclusion. So on all the results that you gathered, how accurate were they? Were there any issues that stopped it being accurate? Was you making mistakes? Did it help you reach your hypothesis or not? And then versus reliability. Was it reliable? If so, why? Or if not, why not? How did you make it more reliable? Just repeat it more times. Simple as that. Okay. I hope that's been useful. Fieldwork is tricky. You also have unseen fieldwork questions as well, whereby they're just going to give you some random scenarios. They're literally just going to read out to you, or you're going to read a piece of text which kind of outlines somebody else's fieldwork. Random, they've made it up. And they'll just give you little questions like this. So a group of students wanted to investigate the quality of footpaths varied in a national park. Students asked 50 people their opinions on the quality of 3 footpaths, A, B, and C. These are our footpaths here. Study figure 4, a table showing the results. Okay, so you can see, just study it for a while. Footpath A has got lots of really good feedback for here as well. Footpath B, not so good. Footpath C is a little bit mixed. Okay, and the first task, you just got to complete the graph. It's called a divided bar chart. So you just need to draw a line where the appropriate place would be using footpath C. Okay, what's missing? So we've got poor has been done for us. Fair has been done for us. So we need to know the difference between good and very good. So very good is 10. So I'm just going to draw a line from 50 to 40 here, and then I'm going to shade in so it matches the key. All right, guys, these questions are just about practice. Just ask your teacher for a bunch of unseen fieldwork questions. You'll start to get a feel for how to answer them. And then it's just some simple graph analysis. What percentage of visitors thought the quality of footpath C was very good? This is an interesting one. Outline the conclusions that the students could make from the data, and then suggest another appropriate method the students could use to present the footpath quality data. So what other graph use? Okay, so don't worry about this. This one here, look at the 2 marks. Footpath A has the highest rating, 1 mark, suggested by the fact that 38 people said they were good or very good. So they're just using data to get that 2nd mark. Okay, and then you need to find another discontinuous data presentation technique like a divided bar chart. Oops, I've lost it. So you'd use a pie chart, you could use a bar graph, or something called a located bar graph. Okay, I hope that's been useful. I can't seem to click off my guy, it's moving. I will speak to you again soon. Guys, give this post a like if it's been helpful, and take care. Have a good one.